Okay, so today we are going to continue with lesson 3, day 2. We do have a quiz on section 3 on Thursday. So the quiz is going to cover what I taught last week and what I'm teaching today. All right, so let me go back and talk about that. Like with our exponential functions, our log functions, when we graph them, are going to basically look the same. So we saw that the exponential functions sort of look like a boomerang. They were reflected sometimes over the y-axis, sometimes over the x-axis, and then they were also shifted left and right. So remember, the basic functions of all the exponential, when we graph them, all had the order pair 0, 1. When we go to graph the log functions, they're all going to have the order pair 1, 0. Now, sometimes when we're graphing these log functions, it might be easier to draw the basic function and then apply the shifts. The shifts are going to be the same like we've done in the past. So for example, if I have a log, and let's say the base function could be log of x. If I have something in a parentheses with that x, and if it's, let's say it's a plus minus, so again, it's opposite of what you would think. So here, this would be a shift to the left. This would be, the minus would be a shift to the right. If I have something like this, log x, and there's something being added or subtracted, like a plus 2, this would be up, this would be down. So when it's in a parentheses with the x, that's going to be left and right. And when it's not in a parentheses and it's just being added or subtracted, that would be up and down. Now, you may also see the up and down. They might write the number in front of the log. This would still be 2 up. So let's go ahead. Now, you can either do a table of values. However, when we're going to do a table of values, we are going to switch the log function into exponential. And instead of plugging in values for x, we're going to plug in values for y. However, an easier way is what's going to be on the next slide, and I'm going to show you what I mean by that. Yes. All right. And I know I didn't go through all the stats. This next slide is actually a screenshot from your textbook. And this is going to have some steps that you could take when you are trying to graph a log function. Now, the other way that you can graph a log function is to turn it into an exponential equation and plug in values. Now, again, normally when we do a table and we plug in values, we're plugging in values for x. In this case, we would be plugging in values for y. And I'm going to show you that on the next slide. But just to describe what's happening in these instructions, what they're telling you here is if you wanted to graph this function, log base a of x, 3 order pairs that would be on this graph, you would take this base, this little subscript here, and you could create 3 order pairs. You would take that number, whatever it is, or if it's a letter, you would put 1 over a, comma negative 1. That would be your first order pair. Again, like I said on the other slide, in the base log function graph, it will always include the order pair 1, 0. Now this is before it's been shifted. Okay, if you have a shift, up, down, left, right, then that point will not be on your shifted graph. This is just on the base graph. And then the other order pair would be a, 1. Now, for example, let me do one that's got a number here instead of a letter. So over here, I have log base 3 of x. If I wanted to graph this without turning this into exponential form, I could take this little 3 and make 3 order pairs. I could do 1/3, comma negative 1, 1, 0, and then 3, 1, and then graph it. I think this might be the easier way when it's just a base function. Now, if it's got some plus minus things to the base there, or to the x, then we're going to shift it. Yes.
Can you apply the shifts to the points?
Yes, that's what we're going to do. That's going to be the easiest way to do these. Because watch what happens on my... So again, this is how you get the 3-order pairs. Know that when that little base is greater than 1, your function's going to be increasing. When that little base is a fraction, it'll be a decreasing function. Always remember that you've got a vertical asymptote at the y-axis. And then from here, your domain, because you've got that vertical asymptote, is going to go from 0 to infinity. Now, if you shift it left and right, that vertical asymptote also moves. The range is always going to be all real numbers. Notice the parentheses around the 0 here because of that vertical asymptote. Actually, not on this one, but on the one after this, it's going to be a lot harder to turn it into an exponential with the shifts in there. So here is a log function. The other way to graph a log function would be to apply your matrix. So let me go ahead and move this y equals to the back. B, A, E. So again, the base, the exponent, and then the answer. So another way to graph a log function would be to turn it into an exponential function and then plug in values. This time, instead of plugging them in for x, I'm going to plug them in for y. So, and I've already got the tables here, but just to walk you through, let's say I set it up. This is the input. This is my output. So here, if I input 0 into this function, you see you get a 1. If I plug in a 1 for the exponent, I get 2. If I plug in a -1, I get 1/2. So then if you wanted to now make these order pairs, remember an order pair is always x comma y, so then you have to flip it around. Everybody with me on that? Now, let's say I use that trick that I showed you on the other slide. Remember, it's the 1 over a, -1. So then if I come over here, remember my a, or my base, is a 2. So if I put 1 over 2, comma -1, I already calculated that. Everybody with me? All right, and then here's the other order pair. It's always 1, comma 0. And then again, if you take the base, comma 1. So instead of having to go through the work of plugging it in, just memorize that previous slide. The 1 over a, comma -1, the 1, comma 0, and then the a, comma 1. So on the next slide, I actually have the graph. Now, these log functions are going to have a vertical asymptote. If you recall from that second slide, quiz, I'm not going to ask you to give me domain and range. I'm just going to ask you to graph the log function. So here is the graph. You can see the vertical asymptote here of the y-axis. And notice my graph, it skims along here and it doesn't touch it. And again, if you took these order pairs again, here's your function, log base 2 of x. Take the little 2, and again, make your order pairs. 1 over 2, comma -1, 1, comma 0, and then 2, comma 1. And then graph these 3 points right here, and right here, and over here. Now, notice I did get like 4, comma 2. I did get more points when I did a table. But again, you can get the general idea by using that trick. Yes. All right, so just like with our exponential functions, when we changed the base, we still had that same order pair, but what would be happening is, like when you plug in a 1, instead of 2 to the first power and getting 2, when you change the base to say 3 to the x power, the order pair here would be 1, 3, and over here, 1, 2. So when we did the exponentials, when we changed the base, it would change the value of those other order pairs. All right, so now here is an example of a log function that they're asking us to graph with a shift involved. Now, if I were to take this function and rewrite it exponentially, doing a table is going to be a bit difficult. So again, if I take my function and move the y to the other side, and now apply the bay, again, notice there's no little number here. When there's not a number there, you assume it to be a 10. It's base 10. So in here would be a 10. So 10 to the y power is equal to x minus 1. Now, if I go and try and find the value of x, it's going to be a bit challenging to do a table here. So instead, what I'm going to do is I'm going to use that 1 over a, negative 1, 1 comma 0, and then a comma 1. And then once I get these 3 points, I'm going to apply the shift. The shift, when it's in parentheses, it's opposite of what you would think. So you would think you're going left, but this would really be 1 unit to the right. So again, I'm going to take, this doesn't have a little subscript, so I'm assuming it to be a base 10. So now let's make the order pairs. So my 3 order pairs here are going to be 1/10, comma negative 1, 1 comma 0, and then 10 comma 1. Once I graph, and this is the graph of log of x, y equals log x. Once I get these 3 order pairs to graph y equals log x minus 1, I'm going to take these 3 and I'm going to shift them 1 unit to the right. All right, let's try this. So now that I've got 3 order pairs from my basic function, let me graph them. So again, let me do the original one in red. And then it's going to be hard to get the 1/10 on here, so because my graph goes by ones, but I'll put it right here. Remember, you have a vertical asymptote, which is your y-axis. Let me go ahead and draw that in there. So it's sort of like your wall that keeps your graph from crossing it. Okay, so now I'm going to go ahead and connect my points. So this would be the graph of just log x. Now I'm going to take these 3 points and I'm going to shift them all 1 unit to the right. Now, when we shift our graph left and right, it also shifts our asymptote. So I actually have a new vertical asymptote because I'm going to shift everything to the right. I'm going to shift my asymptote 1 unit to the right. So this is my new vertical asymptote. And now I'll take all these points and move them over 1 unit to the right. And here would be my graph. So what I'd like to see you do on the quiz is come up with the 3 order pairs for the original and then apply the shifts to the original graph. Because it's going to be too difficult to turn it into an exponential function and then do a table of values. Okay, for this next graph, I need you to memorize that this is a new function. This is the natural log, ln x. So ln x is equivalent, remember we learned about e last week? So this is really equivalent to the log base e of x. You need to memorize this. Now, last week I did an additional file of notes and it was in the module. Let me go ahead and change this, y equals log base e of x. And I'm going to move it around so I can show you it in exponential form. So BAE. So e to the y power equals x. In those notes, I graphed this exponential function, and it was in the module. I told you you didn't have to graph any e on the quiz, but now be aware that you may have to understand that the value of e is approximately 2.71. For your purposes for graphing, what I would estimate e to be is about 2.7. So if I wanted to graph this exponential,